Alright, so our next graph is a semicircle. So know that from a circle, a basic centered one is x squared plus y squared equals r squared. So we're just going to rearrange that to get y by itself. And remember, when we square root something, we get a positive and negative case. So yeah, the positive case is the upper semicircle, and the negative case is the lower semicircle. So you can see it's very similar to a circle when finding domain and range. It usually helps to find the graph first. Alright, so let's graph a few. So this one, y equals 9 minus x squared. So we know the radius is going to be square root of 9, so radius is 3. So this is just a basic centered one. It just goes out 3. So we know domain is between negative 3 and 3. And we can see that the range is going to be between 0 and 3. Alright, so the next one. So forget about the plus 1. We know it's going to be a semicircle that goes out radius 2. And then, as you know, the plus 1 is going to shift the whole graph up 1. And we know that since it starts at 1, it's going to go up to 3. So yeah, there's our semicircle there. So domain is between negative 2 and 2. And the range will be between 1 and 3. Alright, so this next graph, as we know, when things are in brackets, it's going to shift it. So now left to right. So since it's plus 2, we know it's going to shift it to the left 2 places. And then we know that from 9, the radius is going to be 3. So we shift it the center left 2 places, so we get negative 2. And now we go across 3. So we get 1. Negative 5. And the height will reach 3 high. So the y-intercept, let x equals 0. So we get 9 minus 4, which gives us square root of 5. So yeah, domain is between negative 5 and 1, and the range is just between 0 and 3. Alright, so this next one, it's not a semicircle, but I just put it in anyway. So the hint says to find the domain first. So we know that x squared minus 9 has to be greater than or equal to 0. So let's just solve this. So pretty much we know that x has to be greater than 3, or has to be less than negative 3. So what this tells us is that the graph is going to look something like that. So we know that that's the domain there. And from the graph, we know that y is greater than or equal to 0. So remember, even if you don't know the exact shape it goes, you can just always sub in other points to see how you think the graph will form. Alright, so now we're going to move on to square roots. So the basic square root y equals square root of x looks like that. So we know the domain there is x greater than 0, y is greater than 0. So y equals square root of negative x. So you might think that this is not possible, but it's only possible if we sub in a negative number, because two negatives will make it positive. So it'll be square root of negative 1, which is just square root of 1. Square root of negative 2 is just square root of 2. So that's why that can exist. And the last missing shape here, this one. So as you can probably tell, it's just going to look like this. Alright, so let's move on to graphing a few now. So y equals square root of x plus 2. So yeah, generally it helps to find the domain first, so we know that whatever's inside the square root has to be greater than 0. So you know x plus 2 greater than or equal to 0. So now x is greater than or equal to negative 2. So now it's going to look like this. And 1 is set let x equals 0, so we get square root of 2. So yeah, that's your domain. And the range, we can tell y is greater than or equal to 0. So yeah, the next one. Always start with finding the domain first. That's what helps you solve these. And since I'm going to divide through by negative, it flips the sign. So yeah, we know that x is less than 4 over 3. It's going to look something like that. And if we wanted to find the one except let x equals 0, so we get y equals square root of 4, which is just 2. Alright, so the next one. So we know the base what the basic square root looks like. So the minus 3, it's just going to shift it all down. So it starts at negative 3, and it'll go like that. So if we want to find the x-intercept, we let y equals 0, so we get square root of x equals 3, square both sides, we get x equals 9. So the domain of this is x is greater than or equal to 0, and the range y is greater than or equal to negative 3. Alright, and this last one now. So let's just focus on the square root bit first. So 3 minus 6x is greater than or equal to 0. So the x is going to be 3 over 6, so that's going to be a half. So we know it's going to go at a half, and we know it's going to go that way. But now the plus 7 shifts everything up 7. So it'll be like that. So we want to find the y-intercept. Let x equal 0, so we get 7 plus root 3. That'll be the y-intercept. So domain, we know x is less than a half or equal to a half. And the range, we can tell that y is greater than or equal to 7. So yeah, that's your square root graphs. Alright, so the last type of graph we're going to look at are exponentials. So a key thing to remember here is anything to the power of 0 is 1. So the most basic exponential is going to look something like this. And it just cuts through 1. So in this case, it's y equals 4 to the power of x. So you can see that the domain is all real x because there's no restrictions on the x. But for the basic one, the range is y is greater than 0. For this one here, y equals 2 to the power of negative x. This is called exponential decay because of the negative x. See, when it's positive, it's exponential growth. So you can see it just keeps on growing quickly. But exponential decay, it's pretty much the same thing, but it's the opposite. So as you can see, it's just going to decay quickly and head towards 0. And obviously, the power here, when x equals 0, it's going to be 1. So the next one, the negative case, it's just the top one, but it's going to be flipped about the x-axis. So this one's going to look like this. And it's going to cut at negative 1. So this one is just the basic graph shifted up 5 spaces. So instead of cutting at 1, it's going to cut at 6. And that means that at y equals 5, it's going to act as an asymptote. So it will never go past 5. Alright, so this next one, y equals negative pi to the power of x. So remember, pi is just a number, so it's pretty much going to be exactly the same as the one above it. So remember, it's good practice to also label another point. So yeah, so you can just do that on your calculator if you want. Alright, so the last one is a bit different. So y equals 2 to the power of 2x plus 1. So the first thing we're going to do is we're going to figure out when does a power equal to 0. So from solving this, we get x equals negative a half. So that means that when x equals negative half, the y value is going to be 1. Now we can figure out the y-intercept. So that'll be when x equals 0, we get 2 to the power of 1, which is just 2. So now our graph's going to go like that. But I should cut through the 2. And as you can see, domain is still all x, the range is still y is greater than 0.